Example 13, find the reference angle for the given angle. Where did I put my unit circle? Here it is. Find the reference angle for the given angle. So 120 degrees. 120 degrees is here. What's the difference from 120 to the nearest possible, to the nearest closest x-axis? So from 120 to here, that is 60 degrees of rotation. So 60 degrees. That's your answer here. This is the reference angle for 120. So 240 degrees would be here. What is the degree of separation from 240 to 180? The closest x-axis. That is 60 degrees worth of separation. Remember, your reference angles are always going to be positive. And now 60 degrees. 60 degrees is located here. What degree of separation is it from 60 to the nearest x-axis? That's 60 degrees of separation. So all of these have a reference angle of 60 degrees. That will not always be the case. That just happened to be what they did here. Reminder, whenever finding reference angles and it is in radians, these are the easiest ones to do. So for pi over 3, keep the denominator the same, and simply put pi in the numerator. Over here, 7 pi over 4, keep the denominator the same, give the numerator pi. That's it. Sine of 120 degrees. Here's 120 degrees. The sine value is √3/2. Cosine of 240. Here's 240. That cosine value is -1/2. Tangent of 60 degrees. Here's 60 degrees. The tangent value is √3. Evaluate sine of pi over 2. Here's pi over 2 radians, and that sine value is 1. Cosine of pi. Here's pi. That cosine value is -1. And now tangent of -3 pi over 2. Well, here's 3 pi over 2, regular 3 pi over 2. That is a 270-degree rotation. So we now need to do a negative 270-degree rotation, which would be here. And the tangent value is undefined. Find two solutions of the equation in the interval 0 to 360 degrees. Give your answer in degrees. So secant, that's a reciprocal value. So let's change it to its reciprocal of cosine. So cosine of theta or cosine of x equals, now since we did the reciprocal of secant, we have to do the reciprocal of -2√3/3. So just flip that, flip everything, but keep it negative. We now have to rationalize the denominator. Multiply the top and bottom by √3. So we have -3 times √3 over 2. I'm going to carry the 2 over. √3 times √3. Remember, the roots cancel themselves out, leaving you with what's inside the root. Simplifying a little bit further. 2 times 3. -3 goes into itself once. It goes into 6 2 times. So 3 over 6 reduces to 1/2. You're almost fully simplified. Cosine of x equals -√3/2. So our answer is, where in our unit circle do we have a cosine value of -√3/2? Here's where cosine is -√3/2. That's at 150 degrees. It said it wanted the answer in degrees. And then we also have a cosine value of -√3/2 here at 210 degrees. Those are the answers. Example 18. State the amplitude, period, phase shift, vertical shifts, domain, and range. Let's start with amplitude. Amplitude is the number in front of your trig function, and it's the absolute value of that. So it's always going to be positive. So the absolute value of -1/2 is 1/2. That's our amplitude. The period, you're going to look for the variable x. You're going to look at the number in front of that. In order to find a period, you do 2 pi over the number in front of x. And simplify. 2 pi over 2 would just leave us with pi. So the period here is pi. Phase shift. We are now looking to the right of the x value. That would be minus pi. Now I realize that I actually almost made a mistake there, because a lot of times you can just look to the right of the x value, and whatever's there a lot of times is your phase shift. So here it would be right pi units. Remember, it's opposite of the symbol here. So since it's negative, we're not going left, we're actually going right pi. But since we have a number in front of x, there's a little bit of math we have to do. 2x minus pi. Set that equal to 0, and now solve for x. So we actually have a phase shift, seeing how that's positive. That's a positive pi over 2, right pi over 2 units. The vertical shift, that is the number outside of the parentheses here to the right. That is +1, so we are going up 1 unit. I wrote that weird, I'm sorry. Going up 1 unit. Domain of sine waves. It's going to be all real numbers, or negative infinity, positive infinity. And now to find range, here's what you're going to do. You're going to take note of any sort of vertical change. We have a vertical change, we're shifting up 1 here. So we're going to do 1 plus that number in front of our trig function. We're going to do 1 minus the number in front of the trig function. And it gives us 1/2. And 3/2. So our range, make sure you're using, excuse me, brackets. Start with the lowest number first, then the bigger number. That is the range. Example 19, find a and d for the function f of x equals a sine x plus d, such that graph of f of x matches the graph below. Also find f of negative pi and f of 0. I'm going to first try and identify where would my midline be in this particular graph. I think it's going to be at 1. Here's how you can figure out. There has to be an equal number of distance from 1 going to the lower bumper, which I'm going to draw in just a second, and 1 to the top bumper. So from 1, I would go up 1, 2, 3, 4 boxes. From 1 down 1, 2, 3, 4 boxes. Perfect. So 1 is going to act as our midline here. Our top bumper is going to be at 5, -3. So if we now need to figure out, find a, That's amplitude. So from the midline, it took us 1, 2, 3, 4 boxes to get to the top bumper and 1, 2, 3, 4 boxes to get to the bottom bumper. Therefore, we have our A value is 4. D, that is vertical shift from the x-axis. It's also your midline. Our midline is 1. So D, positive 1. Now find F of negative pi. What that simply means is, if x is negative pi, then what is y at that point? Well, here's where negative pi is. And as you can see, y is right there, right on the x-axis. So y would be 0. F of 0. What that means is when x is 0, what is your y at that point? So here's where x is 0. Y at that point is here. So that would be 1.